Hello, my name is Ambrose, and in this video we're going to be solving this LeetCode challenge. So, wildcard matching. Let's read the question and try to understand it first. Given an input string S and a pattern P, implement wildcard pattern matching with support for question mark and asterisk, where question mark matches any single character and the asterisk matches any sequence of characters, including the empty sequence. The matching should cover the entire input string, not partial. Okay. So to understand this question, let's reread it again. And for convenience, I've copied this question to my local dev environment. So let's get to it. So as you can see, we have the same question here, and just a standard TypeScript setup, nothing fancy. And I've also disabled the copilot here. Okay, so let's read the question and try to understand it again. Given an input string S and a pattern P, implement a wildcard pattern matching with support for the question mark and the asterisk, where the question mark matches any single character and the asterisk matches any sequence of characters. So one or more characters, including empty spaces. So it can also match an empty string. And this question mark matches only a character, like a character that has to be there. If it's an empty string, no match. Okay. The matching should cover the entire input string. So S and P should fully match. No, there are no partial matches. If there's a partial match, you return a false. Good. Let's take a look at some of the examples. Okay. So the first example we have is double A and a single A. So this output is a false, and A does not match the entire string of double A. Let's walk through why that is true. So in the first A, we try to compare this A with this A. That's a match, right? So we proceed. We try to compare this A with an A here. Oops, we don't have an A here. So that leads us to conclude that this is just a partial match, and there's no full match. And okay, we move on to the next example. So we have a double A and the asterisk. Here we were told that this asterisk matches any sequence of characters, including empty sequences. So this is just any sequence of characters. This double A and this asterisk, this should match, and true enough, our output is true, and we are given an explanation that the asterisk matches any sequence. Okay. Now, for the third example, we try to match C, B, and the question mark and A. Okay. For the first part, okay, we compare C and the question mark. So we were told the question mark matches any single character. So C and this question mark, these are a match, right? And then, but when we proceed to match B and A, this is not a match. So just like example 1, we have a partial match here, and we don't need that. We need a full match where the string fully matches the pattern. So we conclude this is a false. Okay, we also have some constraints. So both the lengths of the S and P should be greater than or equals to 0, but less than 2000 characters. S only contains lowercase English letters. P contains only lowercase English letters, question mark, and the asterisk, our wildcards. Okay. So let me just split these to the right, and then now let's try to break down the problem. Reading this problem, we've gotten some clues. The first clue is that we are matching you're matching a character at S at this index with the corresponding character in the P in P. So this gives us the clue that we need to identify a pointer which points for S, which points at this index, and a pointer for P which points at the character at this index, so that we can compare the two. And if we have a match, should proceed to compare the next set of characters, right? So let's just write that down. So we need to create pointers for S and P. So I'd call my S pointer I pointer, and my P pointer would be J. This can be anything, of course. Then the other clue we get is that for each character of S and P, for each of the corresponding character of at P, we have to compare the two. So let's walk through something like this. A and this, we compare the two. Are they identical? If they're identical, we move on to the next. We are repeating the same comparison. We compare this and the character at the index of 1, which doesn't exist and is undefined. So we compare the two. Are they identical? No, they are not, because it doesn't exist. So these are false, and like that will allow us to get this output. So something like this again, and then we have this case where we are comparing a character at the 0th index and the character at the 0th index. So in this case, C and this is a wildcard, but then we've been told that this wildcard has to match a single character. So let's get back to the clues first. This tells us that we are comparing for each of these characters. We'll just do a comparison. This just tells us that this is a repeating problem, like with a repeating solution and underlying sub-problem. For this, we'd use recursion because that's a good use case for recursion. So let's just write that down. Use recursion. I can't ever spell recursion. Okay. So we'll just define our recursive function. I'll just call it match. Then this function should accept I and J, right? The index of where we are at S and the index of where we are at P. So I and J. Then for this I and J, we'll just use this as a pointer to point at a character at S and a character at P, and we'll try to compare the two. Now that we've compared the two, we'll have to conclude if we have a match. If this and this is a match, we'll proceed to the next characters, to comparing the next set of characters, right? So let's first define what constitutes as a match. So in this case, what constitutes as a match is that if we have this character and this character as a match, the character at the 0 index at S and P, if they are identical, then that's a match. But we also have some other cases, like the case of this question mark wildcard, and we've been told that this wildcard matches any single character. But the catch is that this character has to be there. This question mark does not match an empty string, so, or undefined. So if we try to point at something that's not there, that's no match. So to ensure that, we need to make sure that the pointer, because we've been told the pattern is the only one that can contain this, while this cannot contain, we'll have to ensure that the pointer at S has to point at a value. So to do that, we can just say that our pointer I has to be less than the length of this string, and that will ensure that the pointer is within the bounds of the length of this string. Okay. So let's just write that down. So define a match. So a match would be like if I is less than s dot length and another condition, right? So the condition would be like, are they identical? So to check for if the characters we are comparing are identical, we just check with this. Are they equals to each other? And then again we have this wildcard, or pj is equals to the question mark wildcard. That would be a match, right? Now if we have a match, if those characters are a match, right, here we have a match. Let's just write have a match. What should we do? We should try to compare the next set of characters, right? For example, let's just do that with an example. Let's say S is equals to AA and P is equals to AA. Yeah, if this and this are a match, we should proceed to try to compare these two also, right? So since I said we would use recursion, we would just call this function on itself again, right? So we'll just say match, match, but this time would increment the position of the pointer I plus 1 and j plus 1 to point now at this A and this A, okay? But now that we've done this, we run into some other problems, right? Because when we have matched this, we'll reach at this condition again, right? And we'll increment I plus 1 and I plus 1, and those would point at some value that doesn't exist. Then they'd be undefined. It would be undefined for S and undefined for P. But when we check here again, if they are identical, that would return like undefined and undefined. So that would make our loop keep going infinitely. So for that we need a base case. Like when this case is reached, like we should stop calling this function on itself. So that would be called a base case. So we'd have to define a base case. Now looking at this example, we've noticed that like when we reach at the end of the string S, we could just stop there because there's no need to compare other characters that don't exist. So our base case can be that if we are at the end of this string and at the end of the pattern, we should just stop there and conclude that the string and the pattern fully match, right? Okay, so let's write that comment for base case. Now okay, so our base case would be if I is greater than or equals to the S dot length and j is greater than or equals to p dot length. If we are at this condition, that it means like our string and pattern fully match. So I would use numbers to represent truthy values and falsy values. So in this case, I'll return a 0 if we have a full match, and any other number that's not a 0 if by any chance we don't have a match. So in this case, since we'd have a full match, I'll just return a 0. Then let's just add another comment that this would represent a full match now. Now that we've handled that, let's handle now the wildcard, the asterisk wildcard. Else if pj is equals to a wildcard, this wildcard. Now let's just write handle logic. Okay, so we'll handle that logic here, but now we've not handled the logic where we have like maybe an AC. If this and this do not match, we have to return a no match, right, and conclude that this string and this pattern does not match. And like I said earlier, I would use numbers to represent true or false. So I said that I would use 0 to represent true for a full match, and for false I would return any other number that's not a 0. So I'll just return, if by any chance we don't have a full no matching set of characters, I'd return a number that's not 0. In this case I'll just return -1. Okay, then let's get back to this, because this is the only last remaining case that we haven't handled. So looking at this, we may have an edge case here, because we've been told here, where is that explanation? This asterisk matches any sequence of characters including empty spaces. So we may have a situation where we'll have a AC and 2000 of these asterisks. So a single asterisk can match this entire string, yet we have like 2000 of these. So this tells us that we don't need 2000 of this, we just need one of these. So we could just keep all of this and just choose the last one, because like this last one should match this entire string, right? Okay, so let's write the logic to handle that. Okay, so that I would use a while loop. I'll just check for while p j plus 1 is equals to an asterisk. The next character is equals to an asterisk. I'll just increment j until, yeah. Now that we've handled that, now let's walk through the logic now of skipping. For that, I'll use another example. Let's say we have an S of A, B, B, C, and another pattern of A, let's say an asterisk and C. So to do that, let's just walk through this function with that. So for the first one, for the first set of characters, we try to compare A and A. This is a match, right? Then we try to compare B and an asterisk. So we run into our case. Now we check, is the j plus 1 equal to an asterisk? No. Okay. Now for this, we need to be able to skip these characters and try to compare this and this, because now we are comparing this substring with this substring. If at any point this and this match, and let's say we had other characters, then we'd keep on continuing trying to compare those. But if this and this are a match, then we can conclude that this substring matches this, right? So to do that, I'll just write a loop. Okay, I'll use a for loop for that, and say for let k is equals to I, now our current position, and k is less than equals to s dot length, then we just k plus plus. Okay, now for each of these, we'll have to compare all of these substrings with this substring, right? So we'll just use our function again. We'll just call it recursively, and if at any point we return 0, it means we have a full match. This substring fully matches this substring, right? So then we conclude that this string and this pattern matches. So let's do that. So let's check. Let res is equals to match k and j plus 1. Now we check here if res is equals to 0, then our substring fully matches with the other substring. So like I said earlier, we would be using 0 to represent true and false values. So if we are returning 0, that it means this is true and we have a full match, right? So this would end the loop. And now if we've got, what about if now we had, like, let's say A, B, D? So we'd go through trying to match this. So we try to match this and this. No, we get a -1. This and this, no, we get a -1. This and this, we get a -1. And we've reached the end of this loop. So what do? That concludes that this S and this pattern doesn't match. So for that, I'll just return a number that's not a 0. So return one. I'll just return 1 in this case, just so that we can distinct the two. Okay, then again, within this loop, we need to check, like, if at any point we are returning 1, then there's no more need to proceed, since we have gone through the entire loop until the end. So why are we still proceeding? So we should just break out of the loop and conclude that this is not this string does not match the pattern. Is equals to 1. Then we just break. And with this, I think we are done with the pseudocode for the helper function, our helper function match. So let's just write a comment here, no match. Now our helper function returns a number, and this function expects us to return a boolean, and a true for a full match and a false for no match or a partial match. So how do we return a boolean from that? So since this helper function, we say that if this function has a full match, this string has a full match, we'll return a 0, and if there's no full match, we return any other number that's not a 0. We could just return match and call this with the starting index at S and P, which would be 0, 0, and check if the value returned is it equals to 0. If we have a full match, it would return a 0. Otherwise, it would return any other number that's not a 0. And if we check if that is identical to 0, it would return a false. And with that, I think we have concluded our pseudocode. Now let's proceed to writing the real code. So since we've written the pseudocode, this would be very quick. Okay, so let's start by writing our helper function. So function match, which takes in I as a number and j, which is also a number, and returns a number. Now let's just follow the pseudocode. So first things first, we need a base case. So our base case is, are we at the end of the string of S and P? So if I is less than greater than or equals to S dot length, and j is greater than or equals to P dot length, then we return 0 for a full match, right? Then now we need to check for a match. So we'd say if I is less than S dot length and SI is equals to PJ, or PJ is equals to the question mark wildcard. If this condition is true, then we need to call this with the next set of characters. So we call match, have to return this, match, but with I plus 1 and j plus 1. Now else if pj is equals to an asterisk. We'll come back to this logic later. Then if we have a no match, we just return a -1. Then now let's handle this. So first of all, let's handle the edge case. So of skipping the contiguous asterisks. So we'll check while pj plus 1 is equals to an asterisk, then we just increment this j. Then now for the final logic, like for the for matching the substring, let's just write that. For let k is equals to I, k is less than or equals to s dot length k plus plus. Now we need to define the result. So just say let res equals to match k and j plus 1. Now we check if the result is equals to 0, then we just return 0 because we have a full match, right? Otherwise, if we've gone through this entire loop and not found any match, we return a 1 here first. Then we also check within the loop else if res is equals to 1, then we can just break out of the loop because we've not found a full match. So we should just exit and return 1, which is not equals to 0, and we return a false. That would be a false indicator that we don't have S and P do not fully match. So the last thing to do is we just have to return and then call this match function with the starting index, which would be 0 and 0, and we check does this equals to 0, and with that we've transformed our results into a boolean, which can be either a true or false. So let's save this and then clear the pseudocode so that it's much neater. And let's just try to run this function. I'll use the lead code. Okay. And first let's run in with the test cases. As you can see, all of them are passing. Let's try to submit it, crossing my fingers. Hope it's accepted. Okay, so as you can see, a solution is accepted. If you've stayed with me till the end of the video, thank you, and I hope you learned something.